Okay, moving on. You'll notice that when we're talking about the Internet Protocol Suite, the main players here are the Department of Defense, known as DARPA. That's where the Internet Protocol was originally set up for communications. And one of the interesting things about TCP/IP networks is that they're distributed networks, which basically means that if one segment goes down, other segments can still continue to work. So you can have a building taken out, but your networking will continue to work, and if your information was saved in a centralized area or a distributed area, if it's still available, you can still reach that, get that information. So the Department of Defense was really big in developing that. And then it became really widely used in universities and other places that held a lot of really important information for the same reason. They could share between different universities and things like that around the world. And if one link went down, it will continue to work, okay? Which, as you can imagine, okay. So the Department of Defense, and then on to universities, and the reason you want it to be distributed like that, I didn't have the recorder on, so I had to say it again. So we had to have the ability to keep these networks up and working. Now that's a good thing and it's a bad thing, because what if there's somebody out there who's doing bad things on the internet? Well, it's not that easy to get rid of them, okay, for that same reason. Okay, so let's back off with it. Well, let's look at these others. So TCP is the main one we're looking at here. Okay, Transmission Control Protocol is one of the main protocols in the Internet Protocol Suite. It originated in the initial network implementation in which it complemented the Internet Protocol. Therefore, the entire suite is commonly referred to as TCP/IP. Now, when you have this little gear over here, it means it's going to take you to the Wikipedia page for TCP. Okay, so just to let you know, if you want more information, there's probably 20, 30 pages on that. Okay, so one interesting thing about TCP/IP, and TCP especially, is that in order to make a connection using TCP, you have to make a connection somewhere, sort of like making a phone call. Okay, so if I make a phone call to Bill, for example, and he answers the phone and says, hello, well, I made a connection. So that's how TCP works, okay? The other main protocol here is called UDP, okay? UDP is sort of like the radio. You turn it on and you hear it, but you don't answer back. Or you yell something at somebody, and they may or may not acknowledge you. But they don't have to, because UDP does not require acknowledgement. So you can see kind of the strengths and the weaknesses there. When you have a protocol that does not require any acknowledgement, what don't you know if your message ever got to where it's supposed to get to? So it's not as reliable as TCP, which requires that you have an acknowledgement for every little bit of information that passes from one computer to another. So TCP is more reliable, but guess what? It's a heck of a lot slower. Okay? So there are certain cases where TCP is used, and for certain cases where UDP is used, but they both do basically the same thing. They communicate information. And how do they do it? They do it over IP networks. Remember, IP is the Internet protocol that lives on the Internet layer, and it basically transfers information between machines. It basically transfers it from network card to network card. So if you have two computers that are talking to each other, it's going to transfer that information from one network card to another network card in a different computer. So, because that's the Internet layer, the networking layer right there. With the link layer, we're getting kind of a mix between the physical and the logical right there. We have different ways of identifying computers, nodes. They're called computer nodes, or routers are actually a computing device. It's actually a node 2 on your network. But some of these other things are for the realm of those network engineers that we're not even going to touch right now. So we kind of beat to death this little layer model here. And this is kind of a typical network here. We talked a little bit about IP addresses. Why do computers have IP addresses? Because they want to know where to deliver your mail to or deliver your messages to. And if you don't have an address, they're not going to know where to deliver it to. Every computer on a network that communicates with another computer on the network has to have a unique IP address. Just like if you're trying to get mail at your house, but you have the same address as your neighbor, you're going to get your neighbor's mail as well as your own mail, and vice versa. So when we're looking at this picture here, we see desktop PCs, and we see smartphones and laptop computers and phones going over Wi-Fi. And we see a router and a firewall and a switch and a server here. In this network, all of these devices need to be on the same network. That means they have to be in the same family of addresses, and none of them are the same. Okay? There's multiple addresses here. Well, we're only going to talk about the IP addresses. When we talk about the IP addresses, we're talking about which layer? The networking layer. Okay, because that's how computers communicate with each other over the network layer. And the TCP part of the TCP/IP is the actual part that pushes it up toward the application layer where you can actually see what's going on. So TCP sits on top of the network layer, and it moves stuff to the wire, gets picked up on the other side, gets moved up to the network layer, and gets delivered to your computer browser on the other end. And that way you can visit a website, and most of the time you know what you're seeing. I say most of the time because there's a lot of shenanigans that can go on in the middle there, and we're not going to be talking about too much of that today. Well, we have routers and switches. Okay, so everybody kind of recognize what this is? Yeah, it's what we would call a router. It's what you would use on CenturyLink, or what you can use if you have a wave network and things like that. When you're on a DSL network like CenturyLink, they're going to have basically a telephone cable coming into your router and plugging into the port that only fits in this one port here, and that's used for getting their signal to your computer so you can talk over the internet. If you go to wave cable, for example, or OLEPen, that both use a different kind of networking, they use cable modems when they communicate. So you have to have a cable modem first that translates their signal from your television cable, basically, into a signal that can be understood by your networking. It's called a modem because it modulates and demodulates and translates the information to your router right here. And then from there you can plug in multiple devices into here. This would be almost like what we call a switch, and we can talk a little bit more about switches in this conversation. But the main purpose here is so you can actually deliver the signal coming from your internet service provider to your computers. Now, when you connect to your ISP, guess what your router is assigned? It's assigned an IP address, okay? And there are two types of IP addresses. There are public and private IP addresses. And we're going to kind of look at that in this section right here where we're talking about public IP addresses and private IP addresses. But first we're going to introduce this thing. We talked about DNS. Remember what DNS is for. So if you put in yahoo.com, the computer turns it into numbers, it sends it over the wire, goes to a DNS server, and that converts it into something that will come up to something that's understandable by you or the computer. It can translate in both directions. Okay, so that's what DNS does. It's a domain naming system. Dynamic host configuration protocol is, unless you have a fixed IP address that you put on your computer by yourself, it's going to be assigned by a router or a firewall or some other networking device somewhere, and your computer will get an IP address from that device using dynamic host configuration protocol, so it can contribute to the communications on an internet. Now, what's a sneaker net? Does anyone know what a sneaker net is? That's when you walk from one computer to another with your sneakers on and you put a floppy disk in the disk drive. Oh. That was the original type of networking. If you wanted to share information back and forth between computers, you use something called sneaker net. Well, this is a little bit beyond sneaker net, okay? After sneaker net, we went to, if you had Microsoft computers, and you were using computers with, like, say, Microsoft Windows 3 or 3.1 or something like that, you would be using a protocol called NetBEUI, which worked over another protocol called NetBIOS. And that doesn't connect to the internet, and that's why we're not using that to this day. But it was a lot faster than TCP/IP, but it only worked in a small network, and you couldn't connect to the internet with it. So pretty much today, whether you have a Windows PC or a Mac or a Linux computer or a phone that's connected to your Wi-Fi network or whatever, you're using TCP/IP network. And your computer uses TCP when it needs to be able to validate information. Let's say you're downloading a file from the internet. How does data travel over the internet? It travels in these things called packets. Packets. P-A-C-K-E-T-S. These little packets of known length travel across the internet, and you don't usually have a whole file in one packet. Usually a packet is one unit of possibly tens of thousands of units that gets transported over the internet. But every time a packet gets transported using TCP, when it arrives at the destination, it gets checked, and it won't finish until all the packets have arrived and they've all been checked, and that way you know that you're getting a solid file, one that has all the pieces. When you're using UDP, it can send files too. For example, the FTP, or the File Transfer Protocol, doesn't use TCP, it uses UDP, and it's a lot faster, but there's no error checking, so you can actually, I think I'm right on that. If it's not FTP, it's a different protocol, but anyway, if you use UDP to transfer files or things like that, there's no guarantee that the whole thing gets there. So there are a lot of factors that can be, need to be considered. But IPv4 is what pretty much everyone is using today. Now, IP stands for the IP protocol. V is for version, and 4 is for its version 4. Okay? And believe it or not, it's not the standard today, but most people are using it. Okay? So, there are millions of addresses that are available through TCP/IP using IP version 4, Internet Protocol version 4. But guess what? They ran out of addresses. Okay? Because a company like IBM has something like 4 million of them. Okay? And a company like HP has another 4 million. You can imagine how you'd run out of them over time. So they had to do something. okay? So they invented this new one called IPv6, version 6, which has billions of addresses available, okay? And we're not going to run out of those, especially since hardly anyone's using it. And the reason people aren't using it is because we have this thing called NAT, which is Network Address Translation, which basically means, and I'm going to say this in as simply as I can, when you connect your router to your ISP, you get a public IP address, okay? One public IP address. Your ISP has a whole bunch that they can dole out. They charge money for them. If you get one that is your own and no one else can possibly use it, you have to pay extra for that. If you get one that can change, it can be shared, and most of the time you don't care, as long as you have one that works, it's a lot less expensive, and you get that address using what we call DHCP, because they have a dynamic host configuration protocol server at their site, which gives you an IP address and other configuration information that you're going to need to make your connections. What kind of information might that be? Well, it might be the name of the DNS server that you're supposed to use to translate information so you can actually get to the websites that you want to get to. Does anybody know the IP address of the main Google DNS server? It's 8.8.8.8, okay? You can use that from your computer if you want, or you can use the one that the ISP gave you. But a DNS server is just going to translate information that you send to it. It's going to turn it into numbers so that it can communicate across the internet. Then it's going to turn it back into something that you can read when it comes back. And then you're going to see in the top of the browser that actually makes sense to you. So we're using IPv4 now. We run out of addresses. Why are we still able to do that? Because we have this thing called network address translation. So in your router, you get one IP address from your internet service provider. And you turn that public IP address into your own private IP address. So for example, if I'm using the IP address that my ISP gave to me to communicate over the internet, does anyone else have that IP address? No, you'd be delivering mail to the wrong house.
Right.
Okay? But inside this device here, you can actually say, take that public IP address and we'll turn it into a private IP address on your own network that you can have hundreds or thousands of computers and devices on that internet that have their own unique IP address on your internal network that all use that one IP address that the internet service provider gave to you, and you can go talk to the internet or other companies and things like that. So private IP addresses, let's see, you can use both IPv4 or IPv6, but there's actually some numbers that are real common. And these, so most of us on our networks at home have for our, if you look at your computer, if I look at this computer right here, let's do an example, because this is really kind of interesting. I wouldn't do anything that's not interesting, right? So, okay. If I bring up the command ipconfig, or ipconfigure, that's what it's short for, you can see that I have two addresses here. I have a 10.10 address, and I have a 192.168 address. And you'll notice that these two, both the 10 and the 192.168 address, are both private IP addresses. Now, what does that mean? That means that they cannot use those addresses to communicate over the internet. If a router on the internet sees one of these addresses, it will just drop all the packets that are going to it or coming to it, trying to go away. It will just drop them because by the rules of the internet, which are known as protocols, these are private IP addresses that are only used in internal networks. And this is how you can use this address inside your network and have 16 million computers on your. If you use this address here, you can have 1 million computers, and most of us have this one here, just like I'm showing you right here, where it says 192.168, which you can have 65,000 computers and devices on your internal network. And they're all going to that one IP address that your ISP gave you. So you can see how if you have 10 computers in your home or office, you don't have to buy 10 addresses. You just need to buy one, or one that's dynamically allocated to you for less money. And you can take all your computers or devices within your network and use a private address. Remember, it's yours, it's private, it's in your network. Public means it's out there in the public on the internet. So you don't confuse those two terms. And you can have multiple systems on your network, like your printer or your 3 computers and your iPad and your iPhone or your Android phone, and those things can all have their own IP address on your internal network and not bump into everybody. Now, if I have an address of 192.168.10.10 on my internal private network, can you have that on your internal private network?
Yes.
Yeah, you can. In fact, everybody in this room can, because that's your own internal network and it's not communicating over the internet. All it's doing is it's talking to your router that has an IP address from your ISP, that when any device wants to get to the internet, we use something called network address translation to translate that from your internal network to something that can talk on the internet. Does that make sense?
Yep.
Okay, so that's why we're still using IP version 4 after all these years, even though we're really close to running out of addresses, because people in the internal networks are now using their own private IP addresses, and you can have lots of them, but they're really only using one public IP address to communicate over the internet. Does that make sense?
Very good.
Good. So let's look at a couple of other things while I have this up here. Okay, so we have something called you see this address here? It's kind of hard to remember, isn't it? It's a little weird. That's an IP version 6 address. Okay? It has a whole different way of working things out, but that's what an IP version 6 address looks like. When you see 2 colons next to each other, that assumes that there's nothing, there's just zeros in there, so you don't have to write out all the 4 zeros. But these can get quite long. IP version 4 address has 4 parts to it, and then it has something called a subnet mask. And rather than getting too detailed and explaining what a subnet mask is basically it's telling you which part of this address is set up for you to use. And you can either have a subnet mask of 255.255.255, or you can have 255.255, and I really don't want to get into explaining what that's all about, but what it really is doing is it's masking a certain part of your address and telling you how many nodes you can attach to your network. And since this is a private IP address behind your router, hopefully behind your firewall, You can set that up any way you want. And the more you understand about how that is used, the more flexibility you have. Now, there's something called the default gateway. What the heck is a default gateway? What's a gateway? When you go through a gate, where does it take you? From one side of a fence to another side of a fence, usually, okay? So a default gateway is usually your router, okay? So if this were my router here, it would have an address of, like your computer, this computer here has an address of 10.0.10.86. What's my router going to have? 10.0.10.1. You see the one up there? So anytime I want to get out to the internet, what do I need to get to? I need to get to this device here.
10.1.
So I have to go to my default gateway, which is going to allow me to go out and talk on the internet, right? And it's going to, so my computer knows how to get to the internet because it knows how to get to my default gateway, which is this device right here, which has an IP address of 10.0.10.1. And then from that point on, our, where's my magic wand? There you go. Presto, changeo, and next thing you know, you're out on the internet and you're going to Sears.com or wherever you want to go, because it knows how to get from your device to your router, and your router knows how to get to the internet, okay? So that's how we are able to communicate from our computers in our home or our office or from our iPads or whatever we're connected to over Wi-Fi, because they all know how to get to our router, because they all have an IP address, a subnet mask, and they all have a default gateway which is on the same network. And the default gateway allows you to go from your internal network outside the fence to the internet somewhere. Okay? Yes?
So the default gateway, is that the one here in this building for you to get to the internet?
Yes. Yes, that is the default gateway for the Shipley Center network,
Right.
which allows me to go out to the internet.
And at home, that would be a different number.
It doesn't have to be, because
It
remember,
could be.
it could be that same number, but most likely it's 192.168.0.1 or 1.1. If I were to put in a search on the internet for a Netgear, if I come over here and I put in default address for Netgear. So for Netgear, if I went out to the store and I bought a Netgear router out of the box, it would be either 192.168.1.1 or 192.168.0.1. Now, does that mean that I couldn't change it to here? Does that mean I couldn't change it to this? I can change it to that if I want. I'd have a whole lot more addresses, but I don't think I'm going to have more than anywhere near 65,000 computers at home. So there's no reason to go that route. They didn't have to use this address, but they did. And I doubt if that was the default. But in a way, it's kind of good not to use the default. Why? It makes it harder for people to guess. Okay, if you use the default password, if you use administrator as your username and password as your password, sure, it will work, but is it real secure? No, because it's easy for someone to guess. In fact, if I were to come on here and I'd say default username and password for Linksys router, for example. So for a Linksys router, which a lot of you have if you've been working with like Comcast or CenturyLink, the admin is a username, or you can leave it blank. Let's see, the password. Let's see. So router name and password are found under the personalized section. That's not going to help us at all. Oh, so the username, you want to put admin into you leave the username blank and you put admin in it as a password. That's what it is. Not very secure, is it? That was kind of a tough one. Let's put Netgear here instead. Netgear, Netgear router. Okay, so the username is admin and the default password is password. So that's what we talk about when we go to the Outlaws meetings and stuff, why you need to change your default username and password. Because somebody can be driving by your house and have a laptop computer or an iPad or whatever and connect to, 192.168.0.1 and connect to your unsecured wireless network and go into your router as admin with the password and change all your configuration from the street, not even know who you are or how it works if you haven't changed these things. Because I found these on the internet. They're out there, and it's really easy to find. So you don't have to be a genius to be able to do it. But it gets pretty insecure if you don't handle it, with some intelligence, some care. So now everyone knows the difference between public IP addresses and private IP addresses. The big difference is public IP addresses are routable on the internet, which basically means that any router, and what the heck is a router? A router is a computer, okay? This is a router, this is a little computer, basically. What doesn't it have? It doesn't have a monitor, it doesn't have a keyboard, but it's still a computer, okay? But a router is basically a computer that handles the function of routing information from one network to another network. That's what a router is, okay? Most routers will have the dynamic host configuration protocol built right into them. They'll often have firewall software built right into them. So you can do a lot of things for security and otherwise with these little routers. They can also get you onto multiple networks. You can also do something called VLANs. You can do plug USB drives into them. All kinds of cool stuff you can do with a router. This one actually takes two USB 3 connections to it. Okay, just a little more time here. If we look at the list of network protocols again. So, application layer. If we just know what the application layer is, basically that's like your web browser. It's an application that you work with to connect somewhere. Knowing that you have to go down and then back up again to communicate with someone else until it gets back to their application layer on their device. And it uses the network layer to communicate using TCP/IP, in our case here, also called layer 3. And it uses the physical layer, which would either be your wireless network or a cable to send data across when you're communicating with other devices. We have all these different protocols. Most of them you can just go, yeah, I don't care. But we do have these ones called Secure Shell. That wasn't there in the beginning, okay? whenever you see SMTP or SNMP, what does the S stand for?
Security.
Simple.
Oh, simple.
Stands for simple, right. Okay, so as you can see here, this will be simple mail transport protocol, simple network management protocol. So the one thing to know about simple, if it says simple, it's complicated. Okay, we'll pause for now. Take another short break here.